Today we're going to talk about the reciprocal rules and quotient rules. So for the reciprocal rule, reciprocal is just 1 over something. So we've already investigated 1 over x. Now we're going to look at 1 over a function. So this would be the same as v of x to the negative 1, and then I can use the chain rule. So I'd bring down the negative 1 times v of x times the derivative of the inside, which would be v prime of x. Okay, to the negative 2, sorry. So this is going to be negative v prime of x over v of x squared. So on my list of derivatives, we can now add and you can use whatever letter v, whatever. So it's negative v prime x over v of x squared. But you can always derive this one by just creating it as a negative 1 power. So we're going to use the reciprocal rule and the power rule to find the derivative of 1 over x to the 4th. So the reciprocal rule is going to be negative x4 prime on top and x to the 4th squared on bottom. So that would be negative 4x cubed over x to the 8th. This would reduce to negative 4 over x to the 5th. Now if I use this as a power, making f of x equal to x to the negative 4, f prime of x is going to equal negative 4x to the negative 5, which we could write as negative 4 over x to the 5th, because the negative puts it in the denominator. So we get the same thing using either method. Okay, so we're going to use the reciprocal rule to find these derivatives. So here, f prime of x is going to equal negative 6 times the derivative of x cubed plus 1 squared over x cubed plus 1 squared squared. So we're going to take this derivative, we have to use the chain rule, so we're going to have 6 times, bring the 2 down, 2 x cubed plus 1 times the derivative of x cubed plus 1, which will be 3x squared. And on the bottom, I'm going to have x cubed plus 1 squared squared is x plus 1 to the 4th. And you can simplify this down further if you want to. I'm going to leave it like that. Here, we're going to have negative 7 times the derivative of cosine squared x over cosine squared x squared. So this is going to be negative 7. Remember, this one keeps coming up. Cosine squared x is equal to cosine of x squared. So my outside function is the squared. Then I'm going to take the derivative of the inside over cosine to the 4th x. I don't really need that parentheses. And again, you can simplify more if you want to. Okay. We did an exploration when we did the product rule where we showed that when you multiply the two functions, it does not equal the derivative of the product. So we're going to do a similar thing here. So I'm going to let f of x equal u of x over v of x. So u of x is x to the 8th. V of x is x to the 5th. So f of x is really x cubed. So the derivative of this is 3x squared. Now we're going to look at the derivatives separately. So the derivative of u is going to be 8x to the 7th. The derivative of v would be 5x to the 4th. So this would be 8/5 x cubed. Well, those two things are not at all the same. So we're going to come up with an actual rule for when we have a quotient. So we're going to derive the quotient rule. So I'm going to simplify this down so we can see it a little bit better. So f is going to be u over v. And I'm going to rewrite this as u times 1 over v. So I'm going to apply the product rule here because I have u times 1 over v. Okay, so it's going to be the derivative of the first times the second plus the derivative of the second times the first. Okay, so derivative of u times 1 over v plus the derivative of 1 over v times u. So this is going to be u prime 1 over v plus this is going to be negative v prime over v squared times u. So this is going to be u prime over v minus v prime u over v squared. I'm going to get a common denominator here, so I'm going to multiply this by v over v. So this is going to be u prime v minus v prime u over v squared. And this is the quotient rule. So again, you want to make a note card of this. So I'm going to do u over v, and if you want to do this with different letters, you can. The derivative is going to be u prime v minus v prime u over v squared. I can use function notation as well, so let's say this is f of x over g of x. So it's f prime of x, g of x, minus g prime of x, f of x, all over g of x squared. So again, just showing you there's different ways we can do these derivatives. So I have 2 over 6x plus 5, and I'm going to use the reciprocal rule. So that's going to be negative 2 times 6x plus 5 prime over 6x plus 5 squared. So this is going to be negative 2. The derivative of 6x plus 5 is 6. So this is a negative 12 over 6x plus 5 squared. Now we're going to use the quotient rule. Okay, so we're going to have the derivative of the top times the bottom minus the derivative of the bottom times the top, all over 6x plus 5 squared. Derivative of 2 is 0, so this whole thing goes away. So we're left with the derivative of this times this. So we again end up with negative 12 over 6x plus 5 squared. Okay, so we're going to do this next one. Okay, so we're going to have the derivative of the top times the bottom minus the derivative of the bottom times the top over the denominator squared. Then we'll take this derivative and this derivative. So this derivative is going to be a negative 2 sine 2x, because we have to use the chain rule, times x, minus the derivative of x is 1. Sorry, guys. All over x squared. Okay, another quotient. So the trick to all of this is just recognizing which rule or rules you need to use. So here we're going to have x squared minus 2x prime times the denominator minus the derivative of the denominator times the top all over the denominator squared. Okay, and then I'll do those two derivatives. So this is going to be 2x minus 2 times x cubed plus 7x minus this derivative is going to be 3x squared plus 7 and x squared minus 2x all over x cubed plus 7x squared. Okay, so here we're going to have 2x plus 3 cubed prime times the denominator minus the derivative of the bottom times the top all over the bottom squared. So then we're going to do these derivatives remembering the chain rule. So this is going to be 3 times 2x plus 3 squared times 2 times 4 minus 5x to the 4th minus this derivative 4 minus 5x cubed times the derivative of the inside, which will be a negative 5, times 2x plus 3 cubed all over 4 minus 5x to the 8th. Okay, our next one. Derivative of the top times the bottom minus the derivative of the bottom times the top all over x squared cosine x squared. Okay, so here we can do this derivative. So we're going to have 3x squared minus 2 cosine 2x times x squared cosine x minus this derivative is a product. So now I need to do the product rule here. So I'm going to have the derivative of x squared times cosine of x plus the derivative of cosine of x times x squared. So I need to do the product rule here, so I still have more derivatives to take. All over x squared cosine x squared. So we have one more row here. I'll squeeze it in. 3x squared minus 2 cosine 2x times x squared cosine x minus, we take these two derivatives, 2x cosine x minus sine x times x squared times x cubed minus sine 2x all over x squared cosine x squared. So at first glance, this one looks super duper complicated, but there's some stuff we can eliminate before we even take the derivative. So I'm going to start rewriting this f of x. Starting with x squared minus 1 is x plus 1 times x minus 1. And multiply that by a sine of x. Cotangent of x is cosine of x over sine of x. And write this as cosine of x times cosine of x. All right, let's look at what we can get rid of. Okay, we have an x plus 1 on the top and an x plus 1 on the bottom. We have a sine of x that will cancel with this sine of x, which will leave me with just a cosine, so I can get rid of those. So this boils down to x minus 1 over cosine of x. So if you can make your life easier, do it. So here, now this is what I'm taking the derivative of. So we're going to have x minus 1 prime cosine of x minus the derivative of cosine all over cosine squared x. So the derivative of x minus 1 is just 1. Derivative of cosine is a negative sign, so that negative will become positive all over cosine squared x. So the moral of the story is here, if you can make it simpler, do it. Okay, so our last problem, we're going to write the equation of a line tangent to this function at the point 1, 5. So we have our point, we need to find our slope. So dy dx, we're going to use the quotient rule. So this is going to be the derivative of the top times the bottom minus the derivative of the bottom times the top there. So this derivative of this is 2, derivative of this is 3, . squared. So we're going to have a 6x minus 4. And I haven't been simplifying, but we have follow-up questions to this. So simplifying that will probably make our lives easier. Minus 9. So this ends up being negative 13 over 3x minus 2 squared. We're going to evaluate this at 1, which is going to make this 13 over 3 minus 2 is 1 squared. So my slope is going to be negative 13. So I'm going to plug this into point slope because now I have to figure out which one of these matches. So I'm going to plug my information into the point slope form of a line. So y minus 5 equals negative 13 x minus 1. And we're just going to simplify this down. I'm going to distribute the negative 13. And then we're going to move it so that the x and y are positive. So I'm going to add 13x over here plus that y, and I'm going to add 5 to the 13. So we're looking for, does this match? And it does. That is the quotient rule.